is one of the sketch of the monitoring system. This part is a specified low power radio wave. So this is installed in the bundle tree. So this node is running by battery. So this solar power type is this part is a solar panel. So 1 centimeter and 3 centimeter square. This is not so big solar panel. So this power is firstly accumulated into a supercapacitor. So by using this monitoring system, we don't need install the battery. So by using supercapacitor, the monitoring system is around 3 days. If the sunlight does not come 3 days, during 3 days, so monitoring system is completely stopped. But maybe I think 3 days is enough to catch the solar power. So all information is concentrated, so transfer to the gateway and then transfer to the cloud server. Why we need such kind of system? The field condition is different in general. So shading top of plant, the temperature and humidity. The temperature is going down and the humidity is going up due to a shading effect. So this information catch by using a field sensors. This is information of the greenhouse. So in Japan, the winter season plant cultivation is very difficult. So we want to catch the information in the greenhouse, environmental information in the greenhouse. So but farmer A. So this red line is the maximum or ultimate point of the leafy vegetables. More than 30 degrees, so leafy vegetables have damage. So farmers have to keep less than 30 degrees in general. But farmer A, he wants to increase the cycle of the plant cultivation. So farmer A does not pay attention for the environmental condition, but farmer B is carefully check environment of the greenhouse. So the accumulative temperature, so accumulation of the temperature is closely related to a plant growth. So this is one of the good information for estimate the plant growth prediction. Sorry. So finally, the farmer A is the period of the cultivation period is around 43 days. Farmer B is 62 days. So quite different. But in this information, the plant information dropped. So we cannot easily explain which farmer is good. So we try to measure the plant health by using a photo camera image like that. So camera module installed into Raspberry Pi. So camera module and around $20. So installed into the computer, so microcomputer. So we take image. So plant with measure scale. So this is a growth profile. By using a scale, so this is a little bit not clear, but by using a scale, we get information of accumulated mean air temperature versus plant height. So plant is all a living thing, so the plant is moved every time. So measurement is not so good, but red point is also linear due to cumulative temperature. If you get this equation by using this part, for example, 4 and 5 days data, so you can predict the 2 weeks later condition. So this is the estimation of the harvesting date. Harvesting date is important to determine the price of the plant or vegetables. If the farmers know about harvesting period before 3 days, market cannot determine the price easily. But 1 week before, 2 weeks before, so they can easily consider. So they can collect the information and they can provide the information to the supermarket, for example. A supermarket may consider about special price day, for example. So this is very important. So prediction, growth prediction is one of the important feature of the ICT application. However, we want to install many sensors into the ground, field, and machineries, and many part of the agriculture. So the number of data is suddenly going up, or sometimes people, oh, this is big data. But how to catch the important information from the huge number of data? This is very important task. So we try to use computer, mathematical analysis to catch the information. So we try to use single spectral transformation. This is one of the eigenvalue analysis, eigenvalue analysis of the mathematics. So principal component analysis can find the differences between the past and the current change of the time series data. First of all, we defined the segment of this data. This is the column vector like that. So this part, for example. So first column vector is here, second column vector is here. So this H is a rectangle matrix. This rectangle matrix have information of this time series data. But this is not square matrix. So we multiply the transpose matrix of H from the right hand side of the matrix H, like that. And then compute the eigenvector and the eigenvalues by using the general method, general computation. So U, large U is a pattern vectors, eigenvalue. This eigenvalue is a profile of this vector time series data. So U1 is a maximum, the eigenvalue for U1 is a maximum eigenvector for maximum eigenvalue. So second is the next one. So if the third one, maximum eigenvalue of the third eigenvector is completely different or completely smaller than U1, U2. In that case, U3 is not important to detect or to estimate this pattern of the time series data. So in that case, we drop U3, U4 as a U1 and U2 is a very important vectors for estimate this profile. And then this method applied to the current stage, so we get this value. Okay, so now I explain about property of the two vectors. If U, large U, and large U bar are same property, in that case, the inner product of two vectors must be equal 1. So 1 minus 1 is 0. So two vector does not change. So changes or value must be equal 0. If two vectors is completely different, so U and U bar is inner product 1. So U is perpendicular to the U bar. So in that case, change point score 1 minus 0. Oh, sorry, 1 minus 0 is 1. Change score must be equal 1. If change point score is 1, become 1, two time series profile is quite different. We can catch the very important information. So change the phase is transformed from previous and current. Why? What kind of event occur in the field? We can catch immediately, for example. So we apply this information, this method into the CO2 concentration in the greenhouse. So we got several change points. Change point high, this part high. What is this? I compared with this data for the farm record. So farmers applied fertilizer to the plant, so change point is occur. So plant is change the profile because the concentration, CO2 concentration is changed, or photosynthesis action is become rare, so CO2 concentration change due to such kind of application. So this one, the third one, Windows is open 3 days. This part, 3 days. So this profile is completely different. So this is immediately catched by eye, but this part is also get by using change point analysis. And other thing, cutting leaves, the photosynthesis action also change. So, but this part, no data, but change point occur. This point is very important. For example, this is occur, the soil microorganism condition change, for example. So we have to catch such kind of information to manage the field. This is how to make the monitoring system. This information also transferred to the farmers. If farmers want to develop the monitoring system by themselves, so we provide the information. So local vendors, IT vendors want to develop the monitoring system. I also communicate each other. So this is a seminar. We can hold seminars. So we can provide or we can assist how to install it like that. He is Horimoto-san. He is one of the CEO of a computer company. So he wants to make a field monitoring system. So he learned how to install, like how to develop the monitoring system like that. Now we finished the field condition monitoring. So next we are going to plant measurement, plant growth measurement and evaluation. By using such kind of task, by doing such kind of tasks, we can get the plant information. So this is a very simple task of the beginning of the image processing. So the sampling rate will be influence the resolution. Which resolution is better, so you can understand it immediately. So the high resolution has many information. So this is a quantization property. So 8-bit or 3-bit, which is a high many information. So 8-bit is more. This is one of the important things. So originally this is image processed image. So the color distribution is different. Brightness is shift a little bit to the right, like that. So by using this line, we can apply the binarization. So this part is black, this part is white. So binarized result is like that. So binarization apply for the red color and black. So in that case, we can take the flower part like that. We also apply this technique to the leaf area detection. Very easy image processing, so we can get the leaf area like that. Leaf area is very important to estimate how can I say, performance of the photosynthesis. So this, we estimate leaf condition by using these images for that. And smoothing to reduce the noise data, smoothing filter is very important, very effective. So this is the original images, this is noise images. So apply the smoothing filter, so noise reduction can be done like that. And this is the edge filter. So by using, this is a brightness curve of this location, this line. So this part is color brightness. Brightness is suddenly changed. Please image equation or curve, equation of the curve of this line. So we apply differentiation of this curve. So the range differentiation of this value is very high. So this part is the edge of images. So this is edge filter, sometimes differential filter.